we will be demonstrating the Doppler effect. The Doppler effect is a change in frequency of a wave. The Doppler effect was created by Christian Doppler in 1842. It looks kind of like this. Crazy. Oh, hi. Didn't see you there. Today we're going to be talking about the Doppler effect. You just watched a car drive by. Did you notice how when it was coming towards you, it sounded like it was a higher pitch, and when it was further away, it was a lower pitch? That's because cool.
Guys, we're in the middle of a video here.
What? So, that is because you were hearing a higher and a lower frequency. When the car is coming towards you, the frequency waves are being pushed together, so you hear a higher frequency, sounding as a higher pitch. When the car passes you, the waves are more spread out because the object is moving this way, so you hear a lower frequency. So I have a beautiful drawing. Okay, this shows an ice cream truck. The ice cream truck is driving down the road. I guess it's just playing the same note. And Becca over here hears a higher frequency than Peter and Austin because the waves are being bunched up, as you can see. So when the ice cream truck drives by her, she'll hear a lower frequency. So, yeah.
Yeah, dude.
Congratulations, today is your day. You're off to learn many great things about waves. You have math in your brains, you have waves all around, and soon you will find that oscillations abound. You're not on your own if you know what I know, but you are the one who will learn how these waves go.
Waves, such as longitudinal waves and transverse waves. This is an example of a transverse wave. As you can see, the particles, i.e. the springs, are moving in this direction, which is perpendicular to the wave's motion, which is going this way. A longitudinal wave, on the other hand, is where the particles move parallel to the spring. As you can see, the parts of the spring are compressing and then coming back, which is shooting them this way, which is in the exact same motion as the wave. And there are other types of waves, such as mechanical and electromagnetic waves. Mechanical waves are waves that move through a medium. And we will be focusing on these waves a lot when we talk about wave interference. Because with wave interference, we are going to be using water waves, and water waves are mechanical waves because they have to move through a medium. On the other hand, light is an electromagnetic wave because light can move through a vacuum and it is still fine. And sound waves are, as you can see, as you saw here, we're an example of a longitudinal wave. And sound waves and light waves also have wave interference. But we're using a water wave in our example because you can actually visualize the wave interference and see the constructive interference and the destructive interference, while us humans haven't developed enough to be able to see sound waves or light waves. So we're going to use a more basic approach that's just basically to show how people visualize what it actually looks like.
Water waves. Party!
Yeah.
Dude.
Sure.
Dude. Okay, I think we're good.
Hey, didn't see you there. Let's talk about waves. Wave interference is a phenomenon that occurs when two waves meet traveling along the same medium. As seen in this picture right here, that is similar to the thing we just did inside the Frisbee, where you see that the water is higher, that's where when you were pressing down here, two crests met, which made what is sometimes called a supercrest. And here, where it's completely flat, is when a crest and a trough met, which just canceled out. So the higher points, that is called constructive interference. And with other things such as like sound, if you did this experiment with sound, constructive interference would be where you hear something louder, while the places with destructive interference, it would be quieter. And as with light, it would be brighter in places with constructive interference and not as bright in places with destructive interference. So when a trough meets a trough, or a crest meets a crest, that's constructive interference. And when this happens, it forms an antinode. And when the opposite happens, when there's a trough and a crest meeting, it forms a node. And if you notice, like if you do this experiment, you'll notice that all the antinodes are in a line, which is called a antinodal line, and all the nodes are also placed in a line when you look at it, and that's called a nodal line. And there's also a central nodal line, which is a line of points that's in the center where the waves from each source always reinforce each other by means of constructive interference. So there's a line like down the middle of it that is always constructive interference.
Cha, dude.